This video will cover the three sections covered in 4.3, 4.4, and 4.5, which look at showing triangle congruence by side, 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 angle, side, hypotenuse, leg, angle, side, angle, and angle, angle, side. So when we're talking about these 5 types of congruences, we have them shown here. Each of these was enough to verify that 2 triangles would be congruent. If you need to check to what it means for 2 triangles to be congruent, you can go back to section 4.2 where we define that. But in this section, it's our shortcuts, so we don't need all 6 things, all 3 sets of sides, all 3 sets of angles, to know we have congruent triangles. So what we're going to see throughout the examples we look at in this section is it's really identifying which of these congruences that work for us. Now, we could have it just as basic as looking at the diagram and saying it's one of these types, or we could go into the proof. And if you have a good understanding of identifying them and the things to look for, it would be very easy actually to fill in the proofs. So before we go into each specific one, we have side, side, side. That's where all 3 sides are congruent. We have 3 sets of sides that match up. We have side, angle, side. That's 2 sides and the included angle are congruent, and the important one about that is the included. Notice that it's angle A and angle D. Those angles are between the 2 sides, where the 2 sides meet. That makes it side, angle, side. Our third one is hypotenuse, leg, or HL, and this only works in right triangles. Now, if we went angle, side, side, that would be a way to identify it, but we're not going to do that. It has to be a right triangle. And to make it easier to remember that it has to be a right triangle, we say hypotenuse, leg. Now, if we remember the hypotenuse in a right triangle is the side opposite the right angle, and the other 2 sides are what we call the legs. So hypotenuse, leg, you need to have right angles, and you need to have a hypotenuse congruent and a leg congruent. If we look up, we have A, B, and D, E there are their congruent legs. It could have might as well have been A, C, and D, F. We just have to have a pair of each. Angle, side, angle is our 4th one. This is where I have 2 angles and the side included between them. This is kind of like side, angle, side, but reversed, angle, side, angle. Our last one is angle, angle, side. This is 2 angles and a non-included side. Notice how our side is not between the 2 angles, whereas if we look at angle, side, angle, it is between. Both of these are congruences. We have to be careful because they do look very similar, but on angle, side, angle, the side is between the angles. On endpoints of the angles, the endpoints of the side is the angles. Angle, side, angle, if we look, there's no side between the angles, so we can't call it angle, side, angle. It'll be angle, angle, side. So there they are together. This is a good diagram to have, or a good reference to look at. You have them all written down. You have a quick reference, kind of a cheat sheet as you go through. This is a good one to go by, and it is in your book in section 4.5 if you want to get it from there. Now, before we get into those more specific ones, let's talk about ones that are not congruent, and these are examples we have. I have a pair of angles, M and A, congruent. I have MA and AT congruent, and I also have this side congruent, and that's reflexive property. We're going to talk about that in a little bit later. But if I look at this, it could be written as angle, side, side, or side, side, angle. This is not one of our congruences. And the reason we do this is, in this case, this could actually be both an acute and an obtuse triangle. It doesn't guarantee that the 2 triangles will be congruent. Now, realize we're not going to have a triangle congruence that is angle, side, side, ASS. So if you get the urge to write that down as a congruence as you're doing a problem, pause and think to yourself, would we really have one that would be spelled that way? Because if we did, then that's what the students would always seem to pick. But no, it doesn't work. It doesn't guarantee congruence. Now, thing to add to this, if you have right triangles, then if I redraw this, let's say my angle's here and here. If I have that, it's not angle side-side anymore, it's actually hypotenuse leg. So hypotenuse leg is a special case of side-side angle where it does work, but if it's not guaranteed to be right angle, it will not work, not be congruent. The other one we have is what we have on the right here. I can make these two angles congruent at angle W, that'd be TWS and VWU, and that's because they're vertical. I have parallel lines here. Anytime we see parallel lines, we want to look for either alternate interior angles, will be very common, or you may get corresponding angles. This goes back to the last chapter. We'll talk about that a little bit later. But I have those are congruent and those are congruent. So if I listed it out, I'd say angle, angle, angle. This one is not congruent either. This one does not work. We need at least one side. If you go back and look at the list of all the ones that work, they all have at least one side. And you could think of that side that matches up, whatever it would be, would guarantee that the shape is set. But I could look at these two triangles where their angles match up, and I could have one that's really small and one that's really big, and their angles could be the same. This is actually what we're going to see later on for similarity. So they are similar, but they are not congruent. So that one does not work. We got to stick with the 5 that work. These are ones we may see from time to time. They do not work. They do not guarantee congruence. So let's talk side, side, side. So we're going to kind of just work through these and look at them as proofs, and we're going to pick up things as we go, things to look for. Now, there's a general process to these proofs and solving these problems. First thing is you're going to be given information. We look at it, we have markings on these diagrams. So you're going to get that given information. The next step you're going to take is what else can I pull from the problem? We're going to be able to pull something else. I've mentioned vertical angles, parallel lines so far, as well as reflexive. Those are things that will help you get to that next step. And then the final step is to look at the triangles and identify which type you have. So all of these will be side, side, side. But if I list it out first, I have KJ is congruent to KL, and I have JM is congruent to LM. So there's two pairs of sides I have. I need one more, and that is actually KM is congruent to Km. And the reason for that is the reflexive property. This will be a very popular one. We're going to see a lot for these types of problems. When it's shared side in both, it's congruent to itself, so it is reflexive. Now we look at our diagram, we have all 3 sets of sides, so I could say that triangle KJM is congruent to triangle KLM, and that's going to be by side, side, side. Now, if we look at the one on the right, we're already given that all 3 sets of sides are congruent, so we don't really have to find anything else. We would list them. Let's just, for this one, name the 2 triangles that are congruent. If I said PRQ, let's move that over. And then I need to find the triangle that it's congruent to. Now, the key thing is you match up the corresponding parts. We have to look, what is P corresponding to? Well, the first thing we might think is it could be T or U. We have to narrow it down, make sure the correct one matches up. If I look where P is in the triangle, it has a line with a single tack mark and a line with a triple tack mark right next to it. These 2 right there. So I'm going to find the angle or the letter in the other triangle that's in the same place, and that does happen to be T in this case. So it will be T, corresponding to R would be U, corresponding to Q would be V, so those 2 triangles are congruent by side, side, side as well. Now we come down to more of a formal proof. We can write that out, but really it's basically what we did in the first one already. but it's good practice. Automatic, what you should always have are those givens. What did they tell you? You already know. KL is congruent to NL. KM is congruent to NM. And both of those are given. So that's what you start with. Where we're going, we want to find that triangle KLM is congruent to triangle NLM. Now, we don't know the reason yet, but since this is the side screen, it's probably going to be side. Now, this is what we start with on any proof. This is what should automatically be written down, your givens and where you want to go. So now all we have left is we just need to go through, we need to find that missing step, and we need to find that reason, because we really already know two things. We know two sides. So what are we going to get to fill in there? Well, we look back at our diagram, and this is where we can usually find that next piece of information. And I have that LM is congruent to LM. And the reason is, well, it's congruent to itself. That is the reflexive property. So now I have side, so my two triangles are congruent by side. On to our next one, side, angle, side. This is where the angle has to be between the two sides. If we look at the first diagram we have in the top left, I have that PR is congruent to NR. I have that MR is congruent to QR. And now I need that last angle. Well, this is the side, angle, side screen. So it's a pretty good hint that we're going to have that angle in between them. That angle in between them is the angles on R. Now we're not going to say R is congruent to R, because if we say that, we don't know which angles we're talking about. We have to name them with the three letters. So if I did N, R, M, it would match up to P, R, Q. And those are a type of angles that are across the vertex from each other. We talked last chapter of them being congruent. They are vertical angles. And we know vertical angles are congruent. So that gives us our three pieces of information. So now we know that our triangles are congruent by side, angle, side. Okay, we look up over on the top right, we have KA is congruent to KT. We have KD is congruent to KS. And we have that the two angles at K are congruent. And we can't call them angle K because we wouldn't know which angles we're talking about. So we're going to say AKD is congruent to TKS. Now this is side, angle, side. Notice our angles between the two sides. The angle is where the two sides meet. It's the point they have in common. So I could even say triangle. Well, I'll just take the letters I used for the angle. AKD is congruent to triangle TKS by side, angle, side. Now we're going to go down and look at a proof. Before we get there, looking back at that top left example, we used vertical angles. That is another one that comes up often. Same with the reflexive property we just looked at. Look for those. The next one we want to see is parallel sides, which we happen to have in this proof. So let's set it up here. First thing we automatically write are those givens. AB is parallel to CD, and AB is congruent to CD. And we want to find that triangle ABC congruent to triangle DCB. Now, those two reasons we had at the top were given. Don't forget that. Automatic right there. So let's look what else we have. Now, we know that AB is congruent to CD. They gave us that. And that's something we can use. But parallel. Why would they tell us it's parallel? We already know they're congruent. They told us that. Now, just because they're parallel doesn't mean they're congruent. But we already know that. So what does parallel lead to? we talked about in Chapter 3 parallel lines cut by a transversal. And in this case, we actually have that. I have my transversal is CB. This angle at angle B and the angle at C are congruent because they're alternate interior angles. So I'm going to say that angle ABC is congruent to angle DCB. And that is the alternate interior angles. My big hint to you, when you see parallel lines, look for alternate interior angles or possibly corresponding angles. They will show up. Why else would they give us parallel? We need congruence. Parallel will usually lead to those types of angles. So back to our problem at hand. We have AB and CD are congruent. We have those angles are congruent. We need one more piece. Now we're thinking side, angle, side. So maybe right now we're asking ourselves, what is that other side I would need to get side, angle, side? Well, AC and BD would not give me side, angle, side because the angle wouldn't be between them. What I actually need is the side BC. Now wait a minute, BC is in both triangles, so BC is congruent to itself, which is reflexive and gives me congruent triangles, and the reason I have them is side, angle, side. The next one we go to is hypotenuse leg. For hypotenuse leg, we must have right triangles. Now, just because it's a right triangle doesn't mean it's hypotenuse leg. But if you do have a right triangle, look for the hypotenuse leg first, because it's typically the one it has is the specialized case. But by no means is it guaranteed to always be that. Now, if we're looking down at the one on the left first, let's list what we know. We know that angle O, call it MON, and angle RNO are right angles. The reason we know that is given to us. Now, that's not enough to say they're congruent. We can say, well, that doesn't say it's congruent, I guess I should say. But we can now say that MON is congruent to angle RNO because right angles are congruent. Okay, we go down to the next. What else do we know? Well, we know that MN is congruent to RO, and that's given. So we need one more piece here. Now we have right triangles. MN and RO happen to be hypotenuse. We need a leg. Well, MO and R, don't really know anything about those, but we do know that ON is congruent to itself. That would be reflexive property again. Sure is popular, that property. Which now when we go back up and mark that, we see that the hypotenuse and the legs are congruent, so we get triangle MON is congruent to triangle RNO by hypotenuse leg. Okay, now that was a proof we needed to prove. That would have been all of our steps, but if it was also something that just said identify what type of congruence it is, those are the process. That's the process you should be going through to check and marking the diagram and making those connections. Now, look at the one on the right. Let's mark what we have. We have XU and WV are congruent. We have right angles at U and W. So we're just going to do this the quick version. Those are congruent, and then I know angle U is congruent to angle W. That's because right angles are congruent. Now I need one more piece. Right now I have a side and an angle. Well, I know that XU, try again, XV is congruent to XV. That's reflexive property. So just as before, we have right triangles. we have the hypotenuse and a leg are congruent. Don't fall into the trap here of saying, oh, I have two sides and an angle, so it's angle, side, side. That doesn't work. It should be hypotenuse, leg. Now we look at angle, side, angle. And the key thing with angle, side, angle compared to angle, angle, side, which we'll look at next, is the side needs to be between the angle, just as when we had side, angle, side. So we look at our first example. I have that angle H is congruent to angle K. I have that HL, the segment, is congruent to KL. I need that other piece of information. Now it's angle, side, angle. So we can kind of have a good idea here. It's going to be this angle here. Now again, we're not going to call it angle L and angle L. We're going to call it angle HLG is congruent to KLJ. Should be angle. And the reason for that is their vertical angles. Now that's one we've seen already, and it's another one you're going to see. That gives you that next step. You now have enough information to say your triangles are congruent, and when I name them, I can just use the same lettering I used for the angle. Triangle HLG is congruent to triangle KLJ by angle, side, angle. Now we go to the right side, this diagram on the right. List what I know. Looking at the top triangle, I have a single marking and a double marking on the bottom. That would be angle QRP is congruent to angle SPR, and those are the single dashes, single arc. I have angle, let's see, QPR is congruent to angle SRP, and that's the angle with the double markings. So that gives me two angles. I'm looking for angle, side, angle, the side in between them. That happens to be PR and PR in both, but wait, it's congruent to itself. That is, again, reflexive property. So now I can mark that. Now I see that my triangles are congruent by angle, side, angle. I can name them QRP is congruent to triangle SPR. Our last one of the five is angle, angle, side. This is where we have two sides, but the angle is not between them. Looking at our diagram on the left, there's our two angles, M and P, and then the two angles at N. Now, if it was angle, side, angle, that means MN and NP would be congruent. These right here. But it's not. It's angle, angle, side is what we're looking for. So let's list what we know. M is congruent to P. Then PNQ is congruent to MNQ. And those are both given. Our next step, our next piece of information we're going to pull from there is that QN is congruent to itself. That is good old reflexive property again, which gives us two congruent triangles. P and Q is congruent to triangle M and Q by angle, angle, side. Okay, we're not going to write out the full steps for this one on the right, but we can also see the same thing again. A and B are angles in the top triangle. Q and R are the corresponding respective angles in the bottom. We have AC and QS are congruent sides. Again, notice if it was segments AB and QR, then it would be angle, side, angle, but the fact it's not between them means it's angle, angle, side. We'll list it that it's ABC is congruent to QRS by angle, angle, side. So we'll do one last example with our angle, angle, side, and angle, side, angle, mainly because we didn't have a proof with them, and this is good because it gets us used to finding the missing information. So maybe it's not, here's all the information, which one is it? It's now, here's what we know, what can we find? So, or what do we need, we should say, to get the congruence that we're looking for? So, number one, I have DE is congruent to MN. I'm going to mark that. M is congruent to D. I'm looking for side, angle, side. In order to have side, angle, side, I need one more piece of information. Well, since side, angle, side has two angles in it, or two sides in it, so we need another side. Now our options for the sides are EF and NO, or DF and MO. But since we're looking for side, angle, side, and we've already said that means the angle needs to be between the two sides, I think DF and MO would be our good choice. So we want DF congruent to MO. And that would give us side, angle, side. So let's clear that off. Go to our next one. Now we're looking at angle, angle, side. So we have FE and ON are congruent, and then FO, or angle F, is congruent to angle O. So we need angle, angle, side. And as we looked at before, that's when the side is not between the two angles. So if I went from one angle to another, I would not be on that congruent side. So if I chose D and M, that's where the sides, the congruent sides, are not between the angles. So angle D congruent to angle M would give us angle, angle, side. For the third one, we have DF is congruent to MO, and we have that angle F is congruent to angle O, and this time we're looking for angle, side, angle. For angle, side, angle, we want the side to be between the two sets of congruent angles. And for that to happen, we would have to have D and M be congruent. Because if E and N were congruent, then that would be an angle, angle, side. It still would be a triangle congruence, but it doesn't fit the angle, side, angle that we want. So now we move down to a new set of triangles. We're going to start with angle, angle, side. We have A is congruent to X, B is congruent to Y, and we're looking for angle, angle, side. So we need the side not between the two congruent angles, two sets of two congruent angles. So that would mean AB and XY are out. Well, let's say we chose AC and XZ. If that was the case, I would have angle, angle, side. That's AC is congruent to XZ. But wait a minute, what if we also chose BC and YZ? In that case, those would also be angle, angle, side, because BC and YZ would not be between the two angles, and that the angle, angle, side would hold up. So we could also say that BC is congruent to YZ. We go to number 5. We have A is congruent to X, AB is congruent to XY. We're looking for angle, side, angle. That's when the side is between the two angles. So if I chose angle B and angle Y, we would have angle, side, angle. Last one, we're looking for angle, angle, side. We have BC is congruent to YZ, and angle C is congruent to angle Z. Angle, angle, side is the side is not between the two angles. So I need to choose the angles so that the side is, again, not between them. And if we look at A and X, that would be angle, angle, side. And if we look at maybe B and Y could still be a congruence. It would be angle, side, angle. But again, we're looking for angle, angle, side in this one.